Good morning, good evening, everyone, and those who joined from the West Coast. So I hope everyone has joined in. So let me just begin with the introduction of mine, and we will move on towards the Kafka. So I am Manoj, and just brief about me. Recently, I started. I have an experience of around 10 years working in on various technologies: Java, J2EE, Apache Hadoop, Big Data technologies, Kafka, Storm, and I'm pretty much comfortable with database as well. So quite an experience with lot many technologies, and recently I started writing something on my own website, and I'm associated with one of the startups, and so there are a lot many things that is going on the the technology front. And recently, from the last 2 3 years, I've started working on developing an analytics platform wherein we are providing the analytic capabilities from any kind of external data source. We will collect any external data from any external data sources, and we will apply our algorithms, machine learning algorithms on that, and providing the analytics capability to the business requirement depending upon how the business wants us to behave. And we have the capabilities like check credit risk evaluation. We have this money laundering detection. We have fraud detection. So we have different kind of analytics capability. We will provide recommendation engines. We will do clustering, data classification. We'll support our customers depending upon how much the tracking time of these support activities. So these kind of various analytics capabilities that I'm currently involved with. So we are developing this. As far as technologies, I have worked very on Kafka from the last few months. I've worked on Apache Hadoop, MapReduce. So these are the the basic introduction of mine, and I hope everyone is aware of the latest technologies, the latest trends that is currently going on, and we have this you must be aware like the biggest thing that is currently happening is lot are revolved around. Now is it fine, Chaitanya? I hope everyone is comfortable with the voice. I thought Chaitanya there is some problem at your end because okay. Oh, that's fine, Chaitanya. Thank you so much, Chaitanya. So okay, Shabir. Yeah, hi Shabir. Thank you. No. Oh, okay. Fine. Let me continue with this. So you must be aware, you guys must be aware, the last from the last few years, there is a lot of things going around the smart world of electronics that we have, like Internet of Things, NoSQL, big data, another lot of things is happening around your, the Facebook, LinkedIn, e-commerce websites. So there are lot many activities, lot many things that is happening around right now. So as a part of this webinar, we will talk about Kafka, like for an hour, and I will try to show you a demo for that in the same. Vikrant, sorry for that. You can just write down your questions here only. I'm not allowed to unmute you. Sorry for that. But you can write down your questions. I'll take your questions and we'll discuss this if you find. Okay, that's great. Thank you, Vikrant. You can write down your questions. We will take it in. I mean, after the session or within between the session, as soon as we end up with some kind of a logic ending, we'll I try to answer your as many questions I can. Thank you, Vikrant. Thank you so much. And where we are, I mean, I'll discuss about like how we going. Sure, sure, Naren. Yeah, we'll hold the question and answer. I'll try to answer the questions as many as we can because it's just a webinar session that we held for a this 1 hour session. I'll try to basically cover the how the Kafka world is going around. What is this buzz around? And the Vikrant question is Kafka. I think Vikrant will take your question during the question and answers are only because we have the limited time. I'll try to cover it and might be your answer will get completed during the session. So I'll try to answer all your questions and all your answers, all your difficulties, your you know during the question answer. Let me, just begin with how the session will held and how I'll introduce you to the Kafka. So what is, I'll discuss this in the what is Kafka and what is this buzz going around this, the messaging platform that we have and its various components that it belongs to and the basic components of the Kafka messaging, this messaging platform. What are the configurations that you can do on your production, on your development environment, and is it the only messaging platform that is available right now, or are there any other? So we'll discuss this, and I'll try to make it a clear like what is happening around. So yeah. So coming back to this picture of the big data that we have. So hope you are aware of all the big data event, the big data classes, the big data technologies, and what is this buzz going around this big data as well. Along with that, we have you know so this is the what we will learn today. And coming back to this, so this is the big data. And in today's world, what we have is very very real time information is getting continuously getting generated at by the applications, like it might be your business application, it might be your social application or any other type of web application that we have. So continuous generation of the data, continuous generation of your the activities that you do on your internet or your Facebook sites or your LinkedIn. So everything is getting generated. The data is getting generated real time information, and this information we need to be reliable. What we want is this information. This information needs to be quickly and reliably routed to different sources so that analytics can be done on these sources. Real time analytics can be done, and we can provide you with some information. So that's the main, the Kafka. And most of the time, these applications they are which are producing the information and the applications which are consuming it, they are well apart and are inaccessible to each other. So this time, the when you are producing some information and when you are consuming information, these are the two separate entities. These are the two separate, the world for between each other. So what we want is we want our integration point to be such that we do not require the redevelopment of the information from here from producer to consumer. What we want is a complete integration point which will automatically help these two entities together, right? So this is the thing, and therefore kind of mechanism, kind of messaging platform is required for so you can say the seamless integration of information from producers and consumers. So to avoid any kind of difficulty, to avoid any kind of rewriting of these applications in between. Ajit, I'll take that question later on. I'll definitely answer this question. Sure. Yeah. In the present era, what we have is the very first challenge is to collect the data. Can you give some examples of? Right, yeah, sure. This is the right question that I can answer, Naren, here only. Just give me 5 minutes. I'll answer that question of yours. Can you give me? Naren has asked the question like, can you give some examples of producer and consumers? Definitely, Naren. Actually, the thing is, we'll come to this in another 3 to 4 minutes. Like, who can be the producers and who can be the consumers, and how you will, how you will interact with the consumers and how you will behave, how the system will behave, and but when it is consumed after it consumed the data. So we'll look into this, Naren. I'll definitely answer this. So the very first challenge that we have right now is to collect this huge data generated by our applications, by our to collect these data which is generated regularly, which is generated in real time. And second challenge is to analyze it. So one part is to collect the data and second part is to analyze the data. So between them, after collecting and analyzing, what we want is seamless integration, seamless movement of the information from collection to the required sources so as to analyze the data. So there, the main Kafka picture that kept up. So you must be aware, you have Facebook. If I talk about your social networking sites, you have Facebook. So you like some comments, you share the videos, you like photos, like videos, comments. So every user activity that you perform on the Facebook, it is getting captured at the end, back end. And for example, I would say your Amazon.com. Fine. Amazon.com, once you, for if you give you an example, suppose you search for a mouse, fine. You search for a mouse and you find it okay. You don't get it something like that you want to buy it. You just cross the browser. So you just close the browser and nothing happened. So next time when you again, come to the google.com and when you try to search something else, not Amazon.com I'm talking about, but when you try to just surf the internet, then you will see that there comes an advertisement which you have searched in the Amazon.com. So there, the real-time analytics is happening. You search the product, you don't buy that product. What you did is you just search it, you just choose it, and you just close it. So, and when you just close the browser, right? After closing the browser, when you again open the browser and surfing some other, what I say, some other websites, there you get the advertisement of the same product that you have searched in Amazon.com. So there, the producers are those events, those clicks, those activities that you were Chaitanya, that's correct. It's very annoying, but it lets you think that if you want to buy it, you can buy it. It's not like Chaitanya, that's a very good point. Like it's very annoying, but Chaitanya, that's how the big data works. That's how the analytics works precisely. Real-time analytics, you can say. So for everyone, the voice is breaking. Yeah, if I'm audible. Okay, fine. Thanks, good. Thanks, Devinder. Thanks, Nitin. Might be I just paused around, so that's why it's not breaking actually. Oh, Chaitanya, I'm so sorry for that. Chaitanya, can you please check your internet connection if I'm not wrong? Because I don't found anyone to be complaining of voice. Okay, thanks, Deepak. Thanks for confirming. Yeah, thank you, Chaitanya. I hope everyone is, I'm audible to everyone. Yeah, so where am I is like, yeah, Chaitanya is, I think Chaitanya told me that it is very annoying him. It is very annoying for him to get those advertisements and all. But Chaitanya, that's how the big data and that's how the real-time analytics is happening. So if you want to try something, you search for any product. You can search for a credit card. You can search for anything. The moment you search, within 24 hours, you will get either a mail, you will get either that advertisement on everywhere. So suppose if you want to search, if you can search for Edureka. Once you search for Edureka and you can suppose you opt for a course, you just close it. But next time when you open your browser, and next time when you try to surf the internet, you will get that advertisement of that particular course on your advertisement list. So that's how it works. Because what happen is whatever you are performing, whatever you are, kind of events that you are generating through your page visits, through your clicks, through any kind of, button pressing or sharing or whatever you are doing, kind of a user activity as a user, whatever you are doing, these events, these activities, these clicks, each and everything is getting captured at the back end, which is acting as a feed to our, you can say, to our distributed system on which the analytics capability is generated through, on which the analytics is happening to get some real-time info. So this all events, activities, where it comes from? It comes only from the data, right? That we have. So right. So it comes from the data. So data is our main ingredient for all the internet application, whether it is Facebook, LinkedIn, your social application, your business applications, whatever you are including. So that's where the big data comes. So one example, this is the, this is the example for your social networking sites. I would like to give you one more example. Like you have a web application, you have your, a web application running on multiple servers, multiple client. So whatever your user, whatever your customers, they are using it. Everything. What I'm trying to say is you have your application running or on your system and you have a web application. So suppose you want to check how much time it will take to load a page. So you can collect those kind of metrics as well. So suppose you can collect your response time of a particular page. You can check your performance of a particular page, your performance of the particular application. So these many things can be captured at the backend through logs, through your, through the patterns, and we can analyze those patterns. We can analyze those metrics to understand how what will be the response time, what will be your page load time, what is the performance of your application, which page is taking much time, which page is taking less time. So these kind of analytics can happen on these many platforms, on these many metrics to understand, right? Today, now, we have the capability to capture each and every human interaction. So we can capture whatever the human interacts with the machine, whether it is your mobile, whether it is your, social networking sites, your web applications, whatever the human is interacting with the electronics, with the gadgets, we have those capabilities to monitor them, to capture them, and to aggregate and to come up with, you can say, to come up with the proposed, or you can say a decision making thing which helps us to understand the how your system is behaving. Suppose in the same example that we're talking about the web application, suppose your response time for a particular duration, like in a 24-hour day, for the 2 3 hours, your application is used by around 1500 users. So at that point of time, you can say that your application is used by many persons, many users. So at that point of time, the performance is quite low. So suppose if you have those kind of matrices with you, you have those kind of metrics with you that these many point. So we can analyze those things and we can make sure, like whatever the data is, and we can analyze those data. We can perform any kind of analytics on this. So I hope we have in today's application the data has become a part of production data and it is used to run analytics. So recommendation engines, I hope everyone is aware, search based on relevance. So I'll give you another example for the recommendation. Sure, Vikrant, I'll do that. I just read your comment. But somehow people are, they might be aware, they might not be aware. So I need to little bit explain each and every point. I'll try to make sure like I'll not explain, much. One example I would give you on the recommendation. Suppose you, for the again the e-commerce website, you you search for a product and it will give you the recommendation what others have buy, or depending upon your user history, depending upon your buy history, it can recommend you. So recommendation engine works on this policy, right? Search space is again on the relevance, like what have you searched previously, what have you bought previously. So these many things can happen on the analytics part. Your advertisements I've already discussed with you, tracking any abnormal user behavior or application hacking. So analytics can be done on, you can say, your, the on the bank part, we can say the fraud detection, the risk evaluation, whatever the things can happen. If you have any application hacking, then we can check it out depending upon various pattern that occurs on the logs. So all the events, all the things are capturing at the end, at the back end, and it will act as feed to the our system. So moving on to, so there is the, in the present big data era, the very first challenge is to collect the data. It is huge, and the second challenge is to analyze it. So one way to solve the problem is by using messaging system. That's what I've already informed you. Like messaging system provide the seamless integration and seamless movement of the information from producers to consumer among many different distributed applications with the help of messages, right? And so before that, I have just introduced you to the the big data one, how the big data is working, how Kafka fits into the system of the producer and consumers. I'll talk about the Kafka, the Kafka components as well here. So Kafka has a components like, before that I would like to introduce Kafka in how it is originally developed, where it is developed, and right now what it is. So Apache Kafka is distributed publish subscribe messaging system. So what it means is like you can produce any number of producers or any number of resources. They can produce those messages. We can have those messages, and we can consume the messages from anywhere by using the whatever the subscribing system is subscribed to the producer. So any number of consumers can consume those messages. So it is a kind of a message broker platform. It is open source, and it was developed earlier at LinkedIn, and now it has becomes an open source project for the Apache. And it is currently, we will discuss like how the Kafka is fast, scalable, durable, and distributed by design. What it means by it has some properties like scalability, distributed, multiple client support, and the real time complex. It provides your real time complexity. So your Kafka is an open source messaging system with the characteristics like the distributed. So if I ask you, if I told you about the distributed, it is like it explicitly supports the message partitioning. You have a message, you can partition those messages across the Kafka servers, which is here termed as brokers. Your broker is equivalent to your servers. So your whatever the messages that you are having, your messages are getting partitioned over the Kafka servers, and distributed consumption can be done over a cluster. So kind of a parallelism is provided while consuming those messages, right? So what happen is you have the Kafka messages. See, this is your producer, and these many are the sources that we have. And once the producer is writing to the brokers, or you can say, just give me a second, I'll show you the scenario. Here we have those producers, we have the Kafka clusters in between, and we have those consumers. So the thing is, when the producer is trying to produce the messages, trying to your producer is something like your Twitter, your Facebook, or your LinkedIn, which is producing continuously producing the messages. These messages are they will be dumped into, or they will be produced to the Kafka cluster, which is a set of brokers that we have, which is kind of a set of brokers. And on that particular broker, you partition your messages, and it will be consumed parallelly by the different consumers. So for example, you have a Twitter stream coming, you divide your Twitter stream into different partitions, which is dumped into your Kafka cluster, or you can say the Kafka broker. And from there, if you have partitioned your Twitter stream into suppose three parts, so you partition them, and consumers will consume separately from these partitions. So this is kind of a distributed architecture that is maintained here. Is everyone able to understand this point? Like you have a stream of messages coming to a particular category. Suppose you on the Twitter you find sports category, you find the stream of messages. You want the producer will publish these messages to the Kafka cluster, which is a set of brokers that we have, and parallelly each consumer will consume those messages. Suresh has asked a question, what is the use of partition? Suresh, partitioning is done used for parallel consumption of the messages. See, if you have lots of messages coming, you don't want, depending upon your case scenarios, you don't want it to be consumed sequentially. You want it to consume parallelly. So that way you partition your messages based on some key value. When you partition them, each consumer can consume those messages from that particular partition. Vikrant, we can use Java as well for writing the code to the Kafka. But Kafka is earlier, Kafka is written in Scala, though we can use Java, and we can, in case we can. I'll show in case we get the time. We'll show you how to produce the messages and consume the messages in the demo. Partition means, Naren has asked, partition means duplicated copy of the same source. No, for duplication, we have a we have the characteristic of the Kafka as replication, where it provides your fault tolerance. But partitioning particularly means to consume those messages in parallel. Suppose if I ask you, if I say, if I have a set of messages consisting of 10 messages, you can say. Fine. I produce three messages to one Kafka broker, three to another Kafka broker, four to another Kafka broker. I want them to consume parallelly. So that way the partitioning is happening. Yeah, Vikrant, I can see the thing is Kafka is basically the producer and messaging distributed system, messaging platform. But your Flume, it is a way of storing and collecting and aggregating the large amount of data. Flume, but just give me a, what if partition, what if the same messages wanted by many consumers concurrently? For that, Naren has asked a very good question. Naren, I'll definitely give you an answer for that. What if the same, Naren has asked a question, what if the same message wanted by many consumers concurrently? For that, Naren, we can create a consumer group, correct? And we, in that particular consumer group, we have multiple consumers associated with it. So kind of a consumer group environment is created from which the consumers will consume those messages. Do you, Ajit has asked a question, do you need to use multiple threads to consume multiple partition messages parallelly? No, Naren, that's not required actually. You can consume those messages parallelly using the consumer configuration even, right? You can run multiple consumers. I'll show you in the demo as well. Like since the architecture is like single node, multiple broker, I'll show you how to consume the messages parallelly. The multiple threads will consume the messages parallelly. So you can set the in the configuration parameter of the consumer, you can set those configurations, and multiple consumers will consume those messages. And for that particular, for what Naren has asked, if same messages want to be consumed, what happen is we create a consumer group so that whatever the consumer whichever consumer is subscribed to that particular broker, it will get all the messages. I hope everyone gets a flavor of this, how the producer and consumer is getting work, right? Yeah, sure. Yeah, Vikrant has asked a question. Just, can we cleanse the data before we put it into the destination? Naren, sorry, Vikrant, that depends upon your scenario. If you want to cleanse the data, that you can do it before, after consuming it. You can put, the layer is like that. You have a streaming messages flow. Fine. You have your Kafka in place. The streaming messages will go to the Kafka, and Kafka producer will publish those messages to the broker, and consumer will consume those messages and put into some kind of a database, some kind of a NoSQL or SQL databases. So after the consumption of the messages, we have we have different set, like you can put it to file, you can put it to your database. So in this way, depending upon your scenario, like after consuming those messages, if you want to cleanse the data, then you can clean it. No, so Kafka is not Kafka is not capable of cleansing the data. It is just used as a publisher, producer, and the consumer. Right. So another question: what is the main differences or advantages of Kafka over Loom when we should be used one over the other? Deepak, we will discuss this definitely. I have this question remaining in me. For example, Vikrant has asked the question: Facebook data we need in Hadoop. So just give me a second, Vikrant. Facebook data. If you have a Facebook data producing those many messages, you can produce those messages. You can publish those messages into the Kafka broker, and then consumer will consume those messages. Right? Okay, Vikrant. Yeah. Suresh has asked, producer is just a place where the data is generated, or is it a Kafka service? See, the architecture is like you provide a producer. Producer is something like you just fetch the data. So if I talk about Twitter, so Twitter has its own API, open APIs, which allows you to get the Twitter. So Kafka is a method of publishing those Twitter messages to the broker. Right, Suresh? So it is just a service to capture the messages from the Twitter or from any other, the streaming data, streaming service, and publish those to the Kafka cluster, or you can say the Kafka brokers. Okay, Chaitanya has asked, can you list a few types of consumers? See, Chaitanya, few types of consumers can be your database, your files. Like if you want to consume, if you have consumed a message, you wanted to publish it to the files for for further analytics. You can do that in the file. You can do that in the, in the NoSQL database. You can do that. You can provide that to some other services for on which you can provide the real-time analytics. So Kafka is just, you can say, a channel of getting the streaming data and putting those streaming data into your SQL databases, your HDFS distributed file system, in whichever way. So it is a layer of, it is a channel between flow streaming data and your HDFS. So right, Suresh? Consumers, Rajiv has asked a question. Consumer can be, Rajiv, we have simple level consumers and the high level consumers available within the Kafka architecture. uh, I'll just give you a brief about like how the Kafka is work. I'll discuss this later on, Rajiv. Broker has to be a Kafka broker. It can be a WebSphere, MQ, or any other. See, Ajit has asked a question like a broker has to be a Kafka broker, or can it be a WebSphere or some other messaging server? See, I think Ajit, you misinterpreted as something like broker is simply your server where you publish those messages. It can be any server where you want your messages to be published. Hello, I'll show you, Ajit, I'll show you one demo of this. Like I have a producer, I have a consumer, how producing the messages, how I'll consuming the message. No, we can, okay, Ajit. Vikrant has asked, Kafka technology, is it Linux? I think with Vikrant, we can, Kafka can run on Windows as well. It's not required, like Linux is required for that. Though we can install Kafka on the Hadoop, on the Linux system as well. Okay, I think see the Vikrant, anything can be captured which is getting generated at the at the like if I ask you about the Twitter end, so we have those tweets, we have those messages. If the if the message is in the format of image or JPEG or any other kind of audio messages, so I think that can be captured, and that can be definitely, the analytics is not restricted to the text only. It is on the images, it is on the video as well. Fine, Vikran, because analytics can be done on anything. It is not restricted to your text only. Okay. Is there a limit on the message or the payload data? No, no, Ajit. There is no limit on the how much you want to produce and how much you want to run on this. So there is no limit on this messages platform that we have. Fine, everyone. Can we use Kafka in Spark technology? Um, so I think Shailesh, we can we can integrate the Kafka. When you learn about the Kafka, we can integrate the Kafka with the Spark, with the Storm, with the HDFS systems. So there we can integrate and we can have the use of the Kafka in the Storm as well. Like this, if you give in, the brief layout, you have your um, you have your Twitter streams on left side. You have your Kafka in between, which is which is producing the tweets into your Kafka brokers and allow you to consume those messages and provide those messages to your Storm application, wherein the real-time analytics can happen. So we can integrate Kafka with the Spark framework, no doubt. That's for sure. And fine, guys. I think we should move on with the so that I can give you fair idea of the the how the Kafka architecture is work and if so. I hope everyone is aware of now the producer, now the consumer, and the broker. So your set of server or your set of brokers is called your cluster. Thanks, Chaitanya. Thanks for confirming. Your the set of servers, your set of broker is called a cluster. Your consumers. In the big data world, I think Naren, there is nothing like as comparable to the Kafka part. But though we have your Apache MQ, you have your Rabbit MQs available as a messaging platform. Though these both of them, the Kafka, the Rabbit MQ, the Active MQ, these are the excellent solutions which work for in the way of message and uh, so that's when, but RabbitMQ process these messages around 20,000 per second, 20,000 messages per second. But Kafka is lot more faster, lot more reliable, gives you the fault tolerance as well, and it provides you the parallelism facility as well, and it will process around 1 lakh messages per second. So that's the way Kafka is far beyond that RabbitMQ and R. How Max Canadian? I mean, in what sense you are asking? That's I told you, right? RabbitMQ process 20,000 messages per second as per the standard, and Kafka process near about 1 lakh messages per second. That to plus 1 lakh plus messages per second. So that's the way the difference between them. So Kafka is a lot more, lot more advanced. Lot if you want, if you have a limited messages, you can use RabbitMQ, no doubt. Kafka comes into the picture when you have lot more events, lot more things happening on the data side, lot more tweets you can say, a lot more streaming data you have. There the Kafka comes into the picture because then only the real capability of the Kafka, you will be able to see the real capability of the Kafka. Fine, Naren? Yeah. So everyone is aware right now, like the producer, the clusters, the consumers. Partitions, I've told you, like if you partition those topics, it will provide you the correct narrative. Other spark or strong. Right. Correct narrative. Because real-time analytics happen in that way only. You process the messages, you get the consumer, you get the messages from the Kafka, give it to the HDFS server or your NoSQL, and from there you can provide a high-end server to run Kafka. No, no, Ajit. Don't you don't require that. Just you want your cluster, your brokers to be efficient. I'll run the Kafka on this machine. I'll show you. You don't require a high-end server. It's just that the configuration and it is just that Kafka gives you the retention period of the logs, retention period of the messages that you want. So depending upon how much messages you are processing, you can add more cluster. That's why it is scalable. So one of the property that we have around Kafka, its scalability only. So why it is scalable? It is scalable. That's just because you can add more servers, more clusters to it to consume the messages to provide the parallelism, right? And we can have those like yeah. So another thing that I would like to hear is about the topics. That's the one thing that I left off. The topics, messages, a stream of message of a particular category is called a topic. So you can say that you implement a Twitter API, you get that Twitter API. So Naren, I'll definitely answer your question while defining the Kafka architecture. Yeah, I hope you will be able to understand. Just give me a few minutes. Just allow me to complete this, the terminology that I'm focusing on right now. Any streaming of messages here in terms of Kafka architecture, any stream of messages of a particular category is called a topic. So here we will not call it a message, we will call it a topic, because a topic is something to which it is a combination of messages of a same type. So that's why it is called topic. So Kafka architecture supports those topics and producer publish those topics. Right, right, Philip. I think I should move on with this. Just give me a minute. Let me, if this architecture is getting clear, further slides will hardly takes time. So this is the main slide where I would introduce you to the producer, consumer, brokers, and all. So I hope the topic is clear. Message, producer, consumer, your broker is clear. So let moves on with the Zookeeper as well, where Zookeeper comes into the picture for this. So Zookeeper is one of the mainstream for this Kafka, which allows it to maintain the synchronization between the Kafka brokers. So you can say it is a centralized server, or it is a centralized service for maintaining the configuration as well as providing the synchronization between the distributed environment and your groups. So Zookeeper and Kafka is like Zookeeper does not maintain any kind of message, any kind of topic. It is just used as that synchronization service, kind of a managerial, you can say managerial role. Your manager is still on your head. So that's way Zookeeper is on Kafka. Fine. So in case of any cluster failure, Kafka failure, so that notification is handled by the Zookeeper. Another thing is like if you have consumed the messages, so offset locations, it is handled by the Zookeeper. I'll come to that part as well. What is offset as well? Like offset, you can think of offset as a position of a particular message. Suppose you have consumed the messages, you have 10 messages, you have consumed a message up to 5. So next time if you want to consume the message, this particular location 6, it will be updated to the Zookeeper, and when next time you can come to consume those messages, it will allow you to consume the messages starting from the 6th part. So that's how the Zookeeper and that's how the Kafka works. So Zookeeper maintains all the relations between the clusters, between the brokers, between the consumer offsets. So kind of a managerial role that I discussed. So it is still on your head. I mean the Kafka. So let me come to this part as well. Like what is the Kafka clusters and how many how it supports. And we have three kind of an architecture. It's Kafka supports three kind of our architecture. Your single node, single broker, single node, multiple broker, multiple nodes, multiple broker. Your single node, single broker, definitely it's your just way of, when I say single node, it means your single server is handling all the broker, and it's just the simple and the clean architecture that is provided by the Kafka, right? And this can be used if you are trying to learn Kafka. This is just the basic architecture that we have already shared here. We have single node and single broker. Your cluster contains only one broker, and so this is the simple and the clean architecture where you can try your hands-on practices on this server. And most of the time, it will be useful if you are trying to build an application to learn the Kafka. So all the processes, all the all the servers, all the brokers, they are running on a single node, and you can say it as a single server. So this is the this is the first architecture point. If you want to, next we will have single node multiple broker. So single node multiple broker means, when I say multiple broker, it means you can have more than one node in the same machine, right? You can support more than one server, one broker, which allows you to publish those messages. Which, when you say multiple broker, it will say the replication comes into the picture in this case. Suppose you publish the message and your replication factor is 2. So your same messages will be replicated across the brokers, so that in case one broker is down, you can still get the message from the another broker. So this is the kind of, when multiple broker comes into the picture, you can say your Kafka is fault tolerance, correct? And this single node multiple broker you can use for your development environment, your testing environment. So this can be used. And so you have, in the earlier model, we have just a simple single broker only, which without much fault tolerance. But here, when it comes to the multiple broker, it means you are providing the replication facility to your topics, to your messages, and your messages are getting replicated to the multiple brokers. Whereon, in case one broker is down, you can get the hold of the messages from the second broker. So automatically Zookeeper will take care of this functionality, the switching between the two brokers, switching between the clusters. So that's how it works. And when you have multiple node, multiple brokers, it again means you are providing the multiple nodes and the multiple broker. Again, this works on your production environment. So this is your single node, single broker that we discussed. You have a Zookeeper keeping the hold of, sitting on the head of your Kafka broker and your consumer. All the producer, they will publish the messages to the single broker, and consumer will consume those messages. So this is just a simple architecture, the simple and the clean architecture you can say that the Kafka provides, which you can use for learning the Kafka. Here it's your multiple broker where you have a cluster, single node multiple broker cluster, like you have a cluster consisting of 3 different brokers, right? And you can produce those messages into any number of brokers you want, and using the replication factor. Sorry. When you say multiple broker, again, it comes into the picture of the replication factor. You are replicating your messages, your topics to different brokers to provide you the fault tolerance capability that Kafka is exhibiting right now. And this is your multiple node, multiple broker, wherein you set of producer producing those messages to any broker in any cluster, on any cluster. So that's how the production environment looks like. So you have the complex architecture, you have multiple nodes, many things are running, and you have a lot many Twitter, a lot many streaming data is coming. You want your application to be fault tolerant, you want your application to be distributed, you want your application to be as fast as it can. So that's how your production environment, that's how the real environment of the Kafka comes into the picture. That's where the real capability of the Kafka can be seen. Correct, Suresh. These 3 brokers, Suresh has asked a question. These 3 brokers act as a separate instance on a single server, single node, multiple broker. Correct, Suresh. I'll show you this, the second architecture on my system only. Definitely, I'll have this. So like for each topic, the Kafka cluster, it maintains your partition, it maintains the log that it writes. So whatever you are writing, suppose you partition your topic into 3 parts. Zero, it starts from the 0, 1 and 2, and you continuously write those messages and appending those messages at the end. So this way, the Kafka cluster, it maintains those partition logs, it maintains those system, and Kafka writes each and everything into that particular partition and appending the message, appending your top message at the end of this. So your partition is your ordered structure, ordered sequence of the messages, and it will not change depending upon your retention hours, how you have configured for that particular partition, right? So suppose if you have, it provides you the capability of retention hours as well, for how long you want to retain the capability of the Kafka, I mean, to retain those messages. So it will allow you to retain those messages till that period. So it is your partition is your ordered sequence of the messages, which is immutable as well, and it is continuously appending to the log. How Kafka achieves fault tolerance? I hope this have. Yeah, definitely, Suresh. Suresh, streaming is only mean you are not updating anything. You are just adding, or as you can say, just appending this data because you don't want to lose the data. If you update or edit something, then you are losing the data. Right, Suresh? We want to capture each and every tweet, for example, just the tweet I'm using it. So we want to capture each and every tweet that is happening at a particular event or for a particular topic. I want it to be captured and publish it to the my server, my broker. You don't need to update it, Vikrant. We just append it. Right, Vikrant, we are just appending it at the end because see the streaming when you provide analytics, you don't want to lose the information in between. Correct. If we are losing the information, if we are editing something, or if we are, you can say the updating the information, then we are modifying it. We won't want to modify it, right? You must be aware, like when there is a any hashtag going on the tweets, so everyone is using hashtag as it. So we'll calculate how this much is getting generated, how the Twitter is behaving for that particular, the news for that particular sports. So we don't want to lose those messages, right? So coming back to the fault tolerance that we have, we will show the Kafka cluster is the partitions that we have, the distributed functionality depending upon the multiple brokers that we have. Kafka achieves that by replicating the messages. Yeah, sure. I'll show you this thing. The Kafka, the fault tolerance demo. I'll show you. You know. So by replicating those partitions over the number of servers, we can achieve the fault tolerance. So let me just go through this. I think we have come with the hands-on with the let's just not waste this time on this part. Let me show you a flair of how this works and how the things are. Show you some files as well. So this is your basic structure. Forget this. This is your basic structure that Kafka is maintaining. See, if you will be able to see this. This is your consumer configuration. Fine. This is my local host. This is the port that is used for Zookeeper. This is your timeout section. This is your consumer group ID. I hope Suresh, you will be able to take care of this. Fine. This is your producer. This is your server properties. Server properties, you can term it as the Kafka brokers. These are the Kafka brokers that I'm maintaining. I've used three Kafka brokers, server one, server two, fine, and I'm opening both of them. You can just check it. I've taken broker ID 0 and port this. Broker ID 1 9093, and for server 2 I'm using 2 and 9094. So these are the three servers I'm using, single node multiple brokers. These are the three servers that I'll use and I'll publish those messages. So there are a lot many configurations when Edureka is giving a very good demo on this, and we are trying to focus on this many technologies, the new one, and let me show you one demo simple. First, the Zookeeper is being started. We need to start the Zookeeper, and I'm running your Kafka brokers. Fine, my Kafka brokers are started, and these are some of the commands that I'm going to use here to create some topics and with partitions, with some of them with partition, some of them without partition. So here I'm using, since my machine is a the Windows machine, I'm using the the configuration of Windows and creating a topic called as test with the simple partition without any replication. I'm just creating a simple. So hope you have seen the created topic test. So this topic is being created. I have not used any partition. I have not used any replication factor. This is the simple without if you do not give the replication factor, if you do not give the partition, this will be created only. I provided the one. I provided replication as well as the partition as one, but this is your value. This file is your file which will contain the messages, and this is your file which will take care of your position, your offsets, communicating with the zookeeper, your index file you can say. This will be used for communicating with the zookeeper and maintaining that. So this is the way where we can create the topics. Fine. And let me give you further example of creating a topic with partition 3 and replication factor as 2. So here you can check these are the two topics that has been created on my server 1, my broker 1 rather, test 2, test 02 and test 201. So if you can check it, these are the three, that I've provided the configuration such that my server logs are getting generated on different location. I can show you here. So these are the, the log directory for my server 1, for my the log directory for my server 2, for server 3. So this is the way of replicating. I've replicated the messages 2 times, so you can see, and I've created the partition 3. So you can see test 2 is being created, it's being divided or is being partitioned into 3, 0, 1 and 2, right? Don't mix with the test 0. You can just focus on test 2 hyphen 1, test 2 hyphen 2, and you can check it out, test 2 hyphen 0. So you have created the topic test 2 with 3 different partitions, and it is being replicated among 2 servers. So at any point of time, if your one server is down, you will still be able to you will have a chance to recover those messages from the another brokers. So in this particular environment, you can say you provide your fault tolerance, you have the capability of parallel consumption, you have the capability of replication is the replicating the messages, so providing the fault tolerance, and the partition those messages for providing your parallel consumption of those messages. So in this way, Kafka is very secure, very reliable in this distributed environment. So let me give you just a flair of how the messages will be produced and how you. So I'm using this as a way to produce the messages. Fine. So I'm trying to consume the messages from the topic test 2. Don't bother this. This is my some machine error. Don't bother about this thing. See, you can see how the messages are getting produced. So if I used, just give me a second, guys. I hope everyone is there. Just give me. Depending on Rajiv, this depends upon how you want to create. I've created single topic partition into 3 times and replicated it to on my servers 2 times, right? So it depends upon if you want to create another topic, you can create another topic using the same command defining different topic name. So depending, whatever we have discussed is like how many topics would be created. You can create n number of topics here. It's just that you need the capability of the server, like the storage capability. That's it. That's the requirement of it. I would like to hear. I had discussed something about the if you have remember my discussion with you guys. Uh, I told you about some consumer group. I hope everyone will remember that if you want to publish a message to a particular to different groups. So that's the way. See, here I am producing a message and it is consumed by only my server one, this one, and this one. Why not this one? I hope I hope everyone has noticed that part. But if I'm producing a message from here, but it is being produced here and here only, not here, right? There is the concept your consumer group. I'll show you my consumer properties as well. See, my consumer and consumer one, these belongs to a single group. So for that particular consumer group, only one can receive the messages. Other will just replicate it, right? So kind of a consumer group has formed. One is your leader. So one is getting the messages at one time. And this is my another, this belongs to my another consumer group. You can check it here. So in that way, you can perform a grouping system. You can have a multiple consumers belong to a consumer wherein you want to receive those messages. Yeah, that's a good question, Rajiv. How the leader is determined, that depends, your manager, how your manager wants you to work. Your leader is your manager only. So here comes the zookeeper. Zookeeper decide whoever it on, you can say it's on the random basis, right? It's on the random basis that is defined. This is defined by the zookeeper, like who will be the leader for that particular. Suppose if you want to consume a message, you write an API. You consume the messages from at that particular time. You consume a message from a particular leader only. So if you want to again make a connection and you want to again implement the consumer API and again comes to consume the message, then you might have a chance that you consume the messages from the second from the different leader from the same group. So it is basically the zookeeper capability, zookeeper synchronization mechanism that can be done on this part. That's a good question, Chaitanya. I think what is the day-to-day task of the Kafka developer? See, Kafka developer, if you ask me about this, once you set up those architecture now, you don't require it to go to the architecture level again and again. What you want is you just need the messages, your continuous streaming flow of the messages, right? Depending upon your scenarios, you see, I told you about some simple consumer APIs and high level consumer APIs. So these are the lot many scenarios that depends how you want to consume the messages. So if you design the architecture once, I think you don't require day-to-day changes for that particular Kafka, right, guys? So this is the simple demo that I can show you right now. Not a problem, Chaitanya. I mean, let's come to the Kafka, the LinkedIn. Apart from this, LinkedIn uses Kafka for many purposes like log monitoring, performance metrics, search improvement. So I hope everyone has used LinkedIn. Suresh, admin task is basically the configuration part. You have a continuous stream flow of the data. You have your data streaming at a very rapid speed. then you want your systems to be such that your messages will not get lost. So you want to consume each and every message. So depending upon your configurations, the admin task belongs to setting up of the Kafka clusters, Kafka brokers, right? Fault tolerance. You're depending upon, suppose in one case you don't require the replication because message topics does not that much worth. So in that particular task, in that particular application, you don't provide the replication. For a particular application, you want we want the parallelism to be at its best. So you provide the partitioning. So you can relate partitioning to parallelism and fault tolerance to your replication. So depending upon your task, depending upon your scenarios, you can use this. I mean, in day to day, you can, if you have an architecture of the big data, if you set up the big data, the complete architecture of the big data technology, so Kafka is just a channel. Definitely, it's just a server, right, Rajiv? You can integrate it with anything. I'm running Kafka on my Windows desktop, so you can run it on the server where you want to produce it. Chaitanya, how does it work with? Thanks, Rajiv. Thanks for the compliment. How does it work with Elasticsearch? See, Elasticsearch is basically used for searching capability. If I'm not wrong, Chaitanya, you have Solar, you have Elasticsearch, you have Lucene, you have lot many searching capability algorithms. So, on which data you want to search? That might be the task. Naren, see, can Kafka be integrated to Cassandra? Definitely, Naren. Kafka, if you can see the Kafka, what Kafka is consuming is the message only. You get the message, or simple, you can say in terms of simple text, saying, I would like to say Kafka is just producing a simple string, simple text. You can store it to any database. You want it to store it to HDFS, you can store it. You want it to store it to Cassandra, can store it. You want it to MongoDB, SQL, no SQL, does not matter whether this whether this is you can integrate to n number of applications the Kafka. It is just producing a simple text. I see a lot of job requirement with definitely the Kafka and the Elastic. Definitely Chaitanya. The reason being is you have the Kafka producing a lot many messages. You store those messages either on your database, either on your distributed file system, or in any server. What you want to do is use the Elasticsearch capability on that particular. So definitely you will see a lot of job requirement at that point. Rajkumar has asked a question: how we decide how many nodes are to be in the Kafka cluster, or how do we know if additional node is to be added to the cluster? See, the second part, how do we know if additional node is to be added? That depends upon your application, the, the kind of load that your application is handling. If you find it comfortable with maintaining a single node, multiple broker, then definitely you can go with that. But depending upon your environment, depending upon your application, you can use n number of nodes to be in the Kafka cluster. It does not matter. But why we want to distribute, the multiple cluster? See, this multiple cluster the multiple cluster the architecture that is being provided by the Kafka, it is just used in case you want your cluster to be region specific. Right, Rajkumar? You want your, suppose India is being divided into north, west, south, east, central. So you want your Kafka clusters, one Kafka cluster for the north region, one for the south, one for the west, one for the east. So that way you can distribute the Kafka cluster. And depending upon your load, your application is handling, you can decide, you are the best person to decide how many nodes you want, how many parallelism, what kind of brokers you need. So that's where you can decide. Devinder, see, I have those commands. You might be, I'm not sure where you are looking at it. But I have the command. You can use this command. I'll share if you can just write it down. You can just write it down. You can do that. I'm not sure what dashboard. What kind of dashboard you are asking? Naren, can you please elaborate your question? Would you please? Rajiv, this is I think I'm not allowed to because I don't have your email IDs. But if it but I think you can get it from something. There is a dashboard for Kafka. There is no option. Can I spin a Naren? I think you can do that. Kafka can be available. You don't see. It's just a when you can run your application on the Windows server, your Linux server, then you can run on any server, whether it's your cloud, whether it's your AWS, whether it's your Azure. Definitely, Suresh. Your broker is your only link, but it depends upon your, if you are that depends upon in the case if you are not providing any replication. You suppose you have four brokers, and your link to you link to the particular broker is broken, right? But still you can produce the messages to the different broker for a different party for a particular topic for a different partition. So in that way, your as Kafka is much more fault tolerance, because in out of four, if your one broker is broken, you still have the capability to publish those messages into different brokers. That's why you provide the replication factor. That's why you provide the partitioning, right, Suresh? I think Devender, I'm not able to open that dashboard that you're talking about. Let me just try once more. I'm not sure where you are trying to open that Kafka dashboard. I have my Zookeeper, I have my both the Kafka brokers running, Suresh, and I have all the things running with me. But I'm not sure where you are looking into this. So it is, Devinder, it is the Kafka dashboard. It is provided by the Kafka and I mean the Kafka community only. I'm not sure, Devinder, but it's not happening with me that I'm not able to open that. So you are saying you are not able to get the the topic, but are you able to create the topic from the dashboard? Yeah, Devinder. Okay, I think you might be not getting that link actually. No, Chaitanya, that's the the webinar is being. Uh, you can use any references. The I hope. Thank you, Chaitanya. Thanks for this. Uh, Devinder, I'll try to figure it out, like why it's not. If I get a chance to contact with you again, I'll definitely share with you something. Just give me a moment, guys. Just give me a moment, please. Rajiv, you can send me your, the LinkedIn actually. I'll I'll catch you guys over there. Rajiv, are you here? You can give me your LinkedIn profile. I mean LinkedIn. Sure. You can give me your LinkedIn link. I'll catch you over there. So thank you guys. Thanks for the time. I hope everyone enjoyed the session. And see, fine guys. I am. Bye bye guys. Have a great time. I'm signing off. Thank you.